So the honest question anyone hitting play should be asking is, why am I listening to these two guys? Well, let me answer that before we get going. David and I spend our time looking at software that's already running inside real companies, not lab samples, not vendors, marketing claims, but the actual stuff that's installed and executing on machines right now. And a few months ago, we pulled the thread on one of those and journeyed through the, we'll call it venerable CVE disclosure process, which, painful as it is, we've managed to run all the way through the coordinated disclosure. And that process is kind of the reason we wanted to sit down and talk. So I'm Josh. I'm the co-founder of Spektion. Before this, I spent a long time as a red teamer, which mostly means I got paid to find this exact kind of issue that David's about to describe and walk through on this call.
I'm David. I'm on the research team. My job is to basically look at all the processes as it run and determine which behavior of all of those is boring and which behavior of it is abnormal or dangerous. It's fun to find, but as we discovered when we dealt with the CVE escalation to the vendor, it's not as much fun.
Yeah, now we'll get there. So, David, tell me what you found. Let's go ahead and start from the beginning, because I know everyone wants to hear about the war story.
Yeah, sure. So the software in question this time is a key switcher. It's primarily used by Russian language speakers. Essentially, what it does is it goes back and forth between Cyrillic and English characters on your keyboard without having to have the Windows method of manually changing the keyboard layout. It's been around since about 2007. It was picked up from the original developer by Yandex in 2008, and it hasn't really changed much since then. It's still technically maintained and it's available for download, but they haven't modified it in a couple years. So what we found is that when the initial program executes, it uses WinExec via punto.exe, which is the primary binary application, to call run-dll32.exe.
Okay. Well, I mean that's totally normal. It's legitimate like Windows program.
Yeah, the problem isn't that it's running, it's that when it runs run-dll32, there's no directory specified in front of it. So it's
Sure.
unquoted. So Microsoft doesn't necessarily know where to look for the application.
Okay. So it's not necessarily that it's running Run 32 DLL. It's specifically that it doesn't actually specify where to pull that executable from.
Yeah, that's it. They just say run dll32.exe, and they don't tell Windows where to find that before they run it.
Right, right.
That's
Okay.
it. That's the finding.
So, lay this out for everyone who's watching. Say you're like a SOC analyst, um, you know, obviously sharp, but you've never had to think about this one. So, why is it missing a directory really a big deal? What does Windows actually do with that?
Sure. So when you run it and you don't specify where it's supposed to run from, Microsoft will go in search order. So it's not necessarily going to go to System 32 where the binary is, and that's what a lot of people assume when they see run dll32.exe. What it'll actually do is it'll look in the current directory. So if punto.exe is in a directory, it's automatically going to look for a binary named run dll32.exe and attempt to run it from there. And if it can't find that, it'll eventually find its way to System 32, but that's not the first place it looks.
Okay. Uh, I know this is the objection I kind of want you to knock down because I'm sure everyone, has one. But okay, cute, but is it actually exploitable or is this more of like a parlor trick? Walk the attack, through it, or walk us through the attack. What does the bad guy actually have to do here?
Sure. So because punto.exe doesn't specify where to look for it, all an attacker would have to do if they were on Box is create any file named run dll32.exe and put it in the same directory as punto.exe. And then because of the way search order process runs, it would call that one before the legitimate run dll32.exe. So that could be a payload, an initial downloader, or whatever the attacker wants it to be.
Right. Okay. So the attacker never really needs to touch like the real program itself.
No, not at all. They don't have to touch punto.exe. It's a signed file. So there won't be any manipulation of the actual application itself. It'll actually just call run dll32.exe as the parent process would be punto.exe.
Got it. Um, so Is this more of like a what, like an unquoted, I guess like a search path?
Yeah, so technically it's CWE 428. So it's unquoted. A lot of times it's called unqualified because the developer doesn't specify the path location. And so CVS SV4 puts this pretty high. It's at an 8.5, but a lot of organizations are still using 3.1. So it's the more common 7.8, which is listed as a high. And it maps really cleanly to MITRE attack technique T1574 with the sub 009, so path interception.
Got it. Okay. So it's a real one, and kind of brings up to the thing that we actually want to dig into. So in this case, here's like the part that should stop anyone that's really watching. I guess the software's been around since you said what, 2007?
Yeah.
Yeah. I assume at this point it's on lots of machines, given that it's almost 20 years old. I'm sure every scanner has probably looked at this at some point and is calling it clean. Um, it's not necessarily that scanners are being lazy though. So what's going on?
Yeah, so scanners and a lot of the behavioral sandboxes aren't necessarily going to be looking for this, right? So the binary itself is all over VT in the usual spots. And because of the people that use it as a pretty large demographic base, like there's a lot of Russian language people that use the application, like it's in the millions. So pretty much every normal scanning location's in there and it marks it clean because it does everything a signed binary is supposed to do. And it's not necessarily calling anything that you would see in a static analysis of the binary
Got it.
as something that they would call malicious.
Yeah. So I mean, I think what you're saying is, file-based scanners are really inspecting what's written, on disk. The binary itself, its version number, any CVEs that are tied to it. But in this case, Punto is going to pass all of those because the installed program is legitimate and it doesn't actually have any known CVEs, at least in the version that was installed. Was it signed?
Yeah, it was signed. It was hash matched and everything. Like
Okay. So it's
the
not really
official
doing
version
like,
from.
it's not malformed in any way. It's not really doing anything truly malicious. It's just executing in a risky way.
Yeah, and the big thing is the flaw isn't in the file, right? The file itself isn't vulnerable. It's the capability that exists with the vulnerability in how they execute it on the system. So a standard static scanner wouldn't see it.
Mhm. Okay. So let me push on that because, when we were doing, red teaming, threat hunting, et cetera, these are the types of things that theoretically, we could look for. Vuln management programs in general obviously are looking for known CVEs or things that exist in the past, but file scans aren't really like the only scanning or static kind of tooling that we've used in the past. I know we've run things like YARA with signature files and hunting like memory for specific patterns. Wouldn't that close the gap in this case?
Not really. I mean, most of the YARA detections that you're going to find, the two primary ways you run YARA, right, depending on the tool you're going to be using, you're going to do a static analysis tool. So you might be able to see the API function or you might see a string, but it wouldn't be confirmed that that will actually run when the binary executes. Some of the other platforms, depending on how performant they are, they'll actually run it once the binary executes. So it'll look at the memory associated with the PID once it's on the stack. And again, you would have a match, but a lot of them wouldn't call out something like this because it's not necessarily doing something malicious. And if it is called out, it wouldn't be called out as potential vulnerability. It might be called out as informational or potentially risky, but it wouldn't really tell you why. It would just flag it. And then you wouldn't have the correlation to what it could do at runtime. You would just say it could eventually do this thing, but we don't know if it will.
Yeah, okay. So you're saying, static tools like YARA would be effective at identifying maybe, flaws that exist in applications, but there's really no way of saying whether or not that flaw is ever exercised.
Yeah, that would be a good
Got it.
thing. And so as a result of that, a lot of people, especially because they're going to be chasing a lot of EDR findings and
Mhm.
the massive amount of CVEs they're trying to patch, this would be very bottom at the barrel if
Right.
it was
Okay.
detected at all.
I mean, with all that said, I guess the big question is if it's not something that you were looking for on disk, then, how'd you go about finding this?
Yeah, we actually observed it at a large enterprise customer that had the Spektion sensor deployed. And Spektion was able to call out this potentially risky behavior based on how it was executing in their environment. So we saw it in the logging that we collect, and we're able to tie it to the process.
Got it. Okay. Yeah, I mean, I can back that up from like the other side of the table. I spent years as a red teamer. Um, in this exact issue, the difference between what's on disk and what a process actually does when it wakes up, it really like this is where, I made a living. Everything that made me effective lived in the space that scanners really just can't see. Watching a tool and actually catch its behavior is kind of surreal for me because I had to do all this like manually every time that we were doing some sort of some stack analysis, basically trying to understand what are the latent risks in software. It was an incredibly manual effort, and now you're saying that you were just observing the telemetry that you were receiving from Spection, and you're able to identify. I'm guessing essentially like system calls or kind of like process events that drove this finding.
Yeah, we were able to see WinExec, as it called, run DLL. And part of my daily stuff, as I highlighted before, is looking at process executions in all of our environments and being able to call out, not that we just have a flagged risk, but that flagged risk could be a pre-CVE indicator. And as I looked into it more, that's what it ended up being. Yeah. And it's not to knock on scanners. I mean, they still have a good use case for other things, but a lot of ETM teams, especially, are not going to be looking at pre-CVE indicators. They're just going to be chasing whatever high-risk CVE that came out that day and attempting to patch or mitigate.
Yeah.
So they don't necessarily have time to look into that.
Yeah, I mean, the alternate, at least historically, has always been when if you even have this level of like insights, then you'd have someone like myself, or I suppose, in your role, on the team that you're going to say, hey, we want to dig into this one. So you need to effectively go in and like reverse the binary or detonate it in some sort of a sandbox. And then you have to write the rules, you have to see if it works. And then really like the hard part on all of that is like, what does that cost? Both in terms of kind of like the manpower, the labor, the opportunity cost for identifying other maybe more exposed software. Um, and I guess that's kind of the question, like if it's that expensive, it doesn't probably scale.
Yeah, it doesn't scale, and even if you say like you had 10 of me or 10 of you, right? Which most
Yeah,
organizations can't afford, usually have one and then
yeah,
a junior, right, to tackle some of the initial stuff. Even if you had 10 of us, the problem isn't necessarily could they eventually look into it, right? You could send a bunch of REs after it. The initial problem is which thing do I target, right? Is you're baselining everything that runs in your entire environment. Inventory is rough enough, but determining what all of those things that you've inventoried, how they operate, and what varies from the baseline of how you think they should operate is just not going to scale, both
sure.
from a cost perspective and just a human perspective.
Yeah,
You
so
wouldn't be able to get to all of it.
so you mentioned watching it at runtime. Like, how does that change the math?
Yeah, the observation is completely passive. Pretty much every end user, unless they're really nosy, aren't really even going to know that the Spektion sensor is deployed. It just observes. So they can still do everything they do. We're completely passive. We're just collecting the telemetry and then analyzing that telemetry for things that we've either flagged previously as malicious or things that we think might be malicious that we'll eventually create a new detection for.
Okay. Uh, let's zoom out, from Punto for a minute, because you caught this because you were watching how the software behaves. So what does that behavior actually tell you beyond, hey, this is a dangerous call? Like if I hand you this piece of running software, what do you get to know about it?
Yeah, so there's basically six things that we derive just from the passive collection that we currently do, right? And this is how we approach every software. It's not like, oh, we're going to go look at Punto, right? So the first one is we want to see how much of a vuln backlog there is in a given software, right? And I think this is what a lot of traditional BTM teams do. They'll
Hmm.
say, oh, it's installed, but they don't necessarily have a way to determine if that attack surface matters
Yeah,
because they don't know if it ran and when it ran, what it did.
sure. Okay. I guess break them down for me one at a time. I guess first off, we can figure out who ran it.
Yeah, so privilege level is really important. So a CVSS 7.8 is going to be very different if we use this one as an example from a standard user who has no privileges or an administrator trying to troubleshoot something or running it. Well, so let's say they want to be able to do Cyrillic and they log in interactively as an administrator.
Yep.
The risk is going to be much higher with them running it versus a standard level user who doesn't have any permissions.
Okay. I assume there's also what it's talking to.
Yeah, so in addition to when you're baselining and seeing how things run and what potential risks with that could be, you also want to know what the network behavior is. So if it creates a listener, what the outbound traffic is, and this will help you determine if it's only going to impact local or if it has the ability to go outbound, if you could be looking at something like potential exfiltration.
Sure. Sure. I guess one of my big questions would be, if somebody does actually pop this, how bad is it?
That's another thing that we look to determine is blast radius. So if something got compromised, what's the worst possible thing that could happen? So a lot of VTM, they might know, you know, it's installed and potentially that it ran in their inventory, but they won't be able to map out if this was compromised based on everything else we know about the environment. Here are all the additional ramifications that it could have.
Okay. Yeah, so I guess coupled with that would be things like what embedded components.
Yeah, so what else is inside it? So applications have libraries that they have associated, and we've seen this a lot with supply chain compromises that are in the news, right? It's not just that we know Punto.exe ran, but it's also really important to see, is it calling any third-party libraries that they potentially don't have any control over? And might this CVE impact other software because they use something that is associated with like Punto as an example?
Yeah. Yeah, I think the most interesting, part to me is it's not necessarily calling out like here's a unknown bad thing, which is no different than what we've probably done for the last 20 years of looking up some sort of vulnerability database, and saying, hey, we've identified a known bad version. But instead, we're actually saying, here's a thing that's going to be bad and nobody even knows about it yet. It's not even named. It doesn't have a disclosure or anything along those lines.
Yeah, so the big thing with behavior two that helps expand your inventory is we're not just looking at things that are in the usual locations. We're just looking for anything that ran. And then once the software runs, what does it do and how does it interact with the system? And
Mhm.
so that gives you a much larger inventory to try to process. And so then you're not just looking at like a CPE string match and trying to match it to a CVE. You're saying, oh, now I have these 9 software applications that I didn't know we had that are capturing keystrokes or that are creating listeners, and we're not necessarily sure what they do.
Gotcha. I mean, like, give me some numbers to make this real. Like, how big of a problem is this really?
Yeah, so in a single customer environment, at one point we surfaced 215 tools that none of the other VTM or inventory applications that they had running on Box had accounted for. So they weren't just installed, they weren't in an inventory, they were actually running. And none of the usual stuff had highlighted them. So in addition to finding those 215 tools, we were also able to not only highlight you have these applications, but here are all the risky things that those applications are doing that you weren't aware of that don't necessarily have a CVE tied to them yet.
Got it. So it's effectively just unknown attack surface, or like what we would classically refer to as like attack surface reduction, more or less exercise. But in this case, you're actually able to prioritize it because you can see truly not just the access level, but what is the inherent risk of allowing that software to exist in your environment.
Yeah, a lot of VTM teams, just because there aren't many companies doing this, right? So a lot of them are still just prioritizing the inventory and then what CVEs are like, say it's 7.8 or higher, and a lot of teams are prioritizing Sysakev or whatever blog came out, right? But that's not a really good way to sort it because you're never going to be able to patch everything. We've been trying to do it since CVEs became a thing. It's not realistic. If you
Yeah,
think you've patched all of your CVEs, that means that the system you're using to identify them is broken. So the big goal is going to be prioritization. And the best way to prioritize things would be based on what the vulnerable software is actually doing versus is it installed and no one's using it.
Sure. Yeah, having lived on that side of the house, I can agree that yeah, the entire process can be maddening at times, especially if you're the one that's doing the patching. And you've got a backlog of a million, vulnerabilities that you need to get caught up on. All right, let's dig into the disclosure, side of things because that's really kind of the point that I want to talk to you the most about. Because frankly, it's kind of the part that nobody makes videos about. You found it. What happens next? Because you can't just tweet like, "Hey Yandex, your thing is broken."
Yeah, and you shouldn't, right? Even though we could go out and just say, here are all these things that are broken and get some clicks or whatever. We're still trying to do coordinated vulnerability disclosure with our CNA. And you want to be able to give the vendor the time to acknowledge that, yeah, it's a real thing, and then prioritize patching so that they can patch it for their customers before anything gets public.
Sure. Yeah. It is a very, convoluted, maybe just complex, system at this point in time. I'm sure I've spoken to lots of people, and they're telling me that it's getting even worse, especially with kind of all the AI generated, vulnerability disclosures. But we didn't, have to do it alone. So thankfully, we have a partner that we can work through to help us with this process.
Yeah, we worked with VulnCheck. So VulnCheck's our CNA
Hmm.
who helps talk to the vendors and do the CVE part. I've worked with the CVE process on both sides now, both as an exploiter and now trying to be a responsible disclosure as a vendor. And I think the AI is just flooding the process. Before it used to be, hey, I've done a lot of due diligence. Here's an example POC, right? Because a lot of people just wanted money. And I think a lot of individual researchers and a lot of companies are just trying to drive the number up, right? We found X number of CVEs, and it's not necessarily things that are inherently risky. It's just a number. So you'll see a lot of lower number CVEs. And so as a result, the vendors receiving them, they just can't keep up. I
Sure.
mean, you have the opposite scalability problem now where there might be a lot of really good things being reported, but they just don't have the cycles to get to them all.
Yeah, it's a highly manual process, even with, all the automation that currently exists. We're still talking about lines of code that need to be, manually verified, understanding both the security as well as the developer, side of it. So, but yeah, I mean, walk me through kind of like how the process went. I know we got a great partner in VulnCheck, but as far as I remember, you telling me it really wasn't like a textbook, case.
No, I mean, the standard, the way it's supposed to work, and what a lot of people will say if they're not honest, is this is how it always goes. You notify the vendor, they acknowledge it, you work together, they ship a patch, everyone discloses on the same day, and hooray, like we did it, right? That's not what happened. So we initially disclosed to Yandex, who is the current supporting vendor for the tool, and we gave them a 120-day window. And other than the initial acknowledgement of like, thanks, we'll look into it if we get time. Essentially, we got nothing after that. So we got no acknowledgement, no patch, nothing.
Gotcha.
So
So
yeah,
there's no fix.
there's no fix. No, I mean, to the best of our knowledge, Punto Switcher is still vulnerable for existing version all the way back. Like we have no evidence that it's ever been remediated.
Yeah.
So
Okay.
you can't even patch it, even though there's a CVE, right? The traditional VTM model sort of breaks down. If there's no remediation or acknowledgement from the vendor, it'll
Sure.
just be something that shows up on your weekly number. It's just
Yeah,
one by one.
so I mean, here's the question, I guess. I can imagine somebody's like yelling at the screen right now saying, if there's no patch and the vendor's ghosting us, then why are we publishing it at all? Why not just sit on it? Or honestly, why not keep it to ourselves or something, for our own product to detect? That's like the gatekeeping move, right? It'd be good for us.
Yeah, I mean, on the exploit side of things, there are a lot of people who do that, right? They'll sell it, they won't disclose it. And as a result, people trying to do any form of mitigation or remediation for software they have installed are just sort of left in the dark.
Mhm.
And that's not what we want to do. We did the 120 days, we didn't get any acknowledgement, but now at least it's out there. Because even though CVE as a process, I've been pretty open about my feelings on that. It's pretty broken, but it's what we have,
Yeah,
right? So if you have this software installed now, at least you know this vulnerability exists and you can attempt to do mitigations. I mean, you can't patch it, but you can at least mitigate. Not publishing doesn't really help anyone, except for potential threat actors that would take advantage of it later.
sure. Well, I mean, that's the thing that I want people to take away, I suppose, is, we're not doing this to wave a scary CVE around. The point is I guess even of watching software closely is just to push the actual state of security forward. And there's a real gap. Stuff only shows up at runtime and nobody's been looking for it. And the choice that we made is to surface it and share it, not to fence it off.
Yeah, I mean, and just because there's no patch doesn't mean you can't do anything. It's super defeatist, right? So there is the potential for a mitigation path, but you can't mitigate what you don't know about. So the whole point of us bubbling this up, obviously our customers knew about this well before publish, but the whole point is you can't mitigate something that you don't know is there. So a lot of people have Punto, especially if they're in the regions where Russian language and Ukrainian language speaking individuals work, which is pretty prominent. You're not going to be waiting on Yandex. So you can take action and do mitigation, or just make the decision to completely uninstall it. Like, there are a bunch of avenues that you could do with respect to mitigation that don't require a patch.
Sure. All right, I get the point. Before we wrap this up, I just kind of want to know, is this a one-off thing, for us here at Spection, or is there more coming?
No, I mean, right now, we're just dealing with the how many do we escalate? Like, how many cycles do we have to deal with the CNA? So there's another unquoted path issue in MOBA Xterm that we caught the same way. And there's a lot of software I think that people would be surprised in 2026 is still operating in a lot of insecure methods. And I feel like it's just going to get a lot worse dependent on how much vibe coding you do, right? And how much maintenance and scalability you have. I mean, we've all seen the layoffs. I just think the problem's going to get worse. But no, to answer your question, we've got a pretty substantial queue. It's just how many can I get over to VulnCheck at this
Sure.
point?
So I guess, if there's any, vendors that are watching this or product teams watching this, what's, I guess, a hope that you take or you hope that they take away from this?
Yeah, I mean, the big takeaway for vendors, especially vendors that we report to, is please answer your disclosure emails. It make my life a lot easier, and we generally are able to provide a lot more evidence than a standard researcher or standard reporter would be, because we're not looking at source code. We're looking at things that are actively occurring in production environments from a lot of your customers. So the weight of our report should go a lot longer than just like, hey, I ran a static analysis utility with Mythos, and I think this might be bad.
Yeah.
We'll be able to tie it directly to the exact process that's doing it in the exact context that we found it.
Yeah, no, it's a good place to land. I mean, it's really the whole reason why we're doing this recording here. There's a layer of risk that only shows up when your software runs. Most tools were never built to look for it. And frankly, we'd rather surface it and talk about it in the open than treat it like it's some sort of magical secret. If you're curious what that layer looks like on your own environment, you know where to find us. But mostly, say thanks for watching, and please go answer your disclosure emails.
Yes, please. Make my life so much easier.
All righty. Thanks so much, David. I'm sure we'll be recording more of these here in the future. And thanks for everyone that joined us on this call. Cheers.
I guess.